So this is the bonding in graphite. So this is one layer. This is first layer. And in graphite, each carbon is having one electron which is free. Each carbon is having one electron which is free. That's why graphite is good conductor of current electricity. Now, so the layers are present one over each other. Just the page of copy or book. This is the second layer. So there is perfect distribution. There is perfect distribution in between the different layers, and they are arranged like this. There is hexagon. There is hexagon in each and every ring. This is the ring, hexagonal ring. This is the second layer. Similarly, there will be third layer. And there is the force of attraction between different carbon atoms. And this force of attraction is called as van der Waals forces. So children, van der forces are very poor force of attraction. They are very poor force of attraction. And as a result of this, you all know, graphite is smooth. Graphite is slippery to touch. Graphite is very soft. So all these properties are due to the presence of van der forces. Van der forces are very weak forces of attraction. Just you can imagine. You know, pencil is slippery to touch. The dust of pencil is slippery to touch. Why? Because the layers can be slide. You must have noticed. As a result, in spite of having very high melting point, the melting point of graphite is around 3500 degrees Celsius. Very high melting point of graphite. But graphite is, very soft substance. Due to this property, high melting point and softness, graphite is used in the preparation of high quality lubricants. Lubricants like engine oil. Engine oils of best quality. You must have seen engine oils. They are slightly dark in light, grayish in color. So they have the particles of the graphite. Similarly, grease. You must know machines, ball bearings, bushings, mechanics. They apply grease. You know grease. So grease also contains graphite. The ultimate particles of graphite, so as to work throughout the time period. And so, due to friction, the temperature is not rises. Otherwise, you take the case of any oil. What happens when we keep oil, rubbing? Oil becomes hot. Oil will burn. But graphite engine oil, you see, engine is so hot. In spite of that, engine oils remain as it is. And so this is an important application of graphite. So that's why the 3 points of graphite, it is good conductor of current electricity because each and every carbon has one free electron. How? Carbon, atomic number 6, configuration 24. So only 3 electrons are consumed. Only 3 electrons are consumed. If we draw the bonds like this, so only 3 electrons are consumed. This is the bonding. So 3 electrons are consumed. So 1 electron is left with every carbon. So this is the first point. Graphite is good conductor of electricity. Second is, graphite is slippery to touch because the adjacent layers, they are placed one over each other and are held together by van der Waals attractive forces. So they can be slide over very quickly. So slippery to touch, very soft substance. Now third is, Graphite is, it is highly stable. So the stable means the melting point is very high, boiling point is very high. So this is due to the very strong force of attraction between these bonds. These bonds. Only the poor forces or very poor forces, van der Waals are between different layers. So this is a very important point about the graphite. Now, when we compare with diamond, in case of diamond, each and every carbon is attached to neighboring 4 atoms. All the 4 atoms are consumed. In graphite, only 3 are consumed. In diamond, all the 4 atoms are consumed here. So there is tetrahedral attachment like this. This is the 3 fingers they have. So if we rotate in any manner, always 1 will on the top, 3 will toward the bottom. Now if you see this tetrahedral, the bond angles, they remain as it is. And here see, now you must know diamond is the hardest material, hardest substance on earth or substance in universe. Why? Because of the compactness of the different atoms. Atoms are so compactly placed that it makes the hardness or one of the strongest material. So this carbon, like this, again this carbon, see the complexity, how it becomes complex. Again this carbon, you can take any carbon. So you can imagine the compactness in diamond. That's why diamond is the hardest known material. Nothing is stronger than diamond. And so diamond is used, children must be surprised that the diamond is used in making the windows of the spaceships. The spaceships, they move at very high speed, otherwise glass will melt. So diamond crystals, diamond embedded window panes are prepared to maintain the high temperature friction. And one more point about the hardness for your reference, that the hardness is measured, hardness of any substance is measured by a scale called as Mohs scale. Mohs scale. Mohs scale. Name of scientist Mohs. And it is 1 to 10. Moho. Unit is Moh. Unit is Moh. And so diamond, like we say, 10. So very simple parameter. Diamond can mark on any substance. This chalk is very soft. Chalk has this around 1. 3 nails are having 3. Similarly, iron 8, copper 7. Now there is particular sequence that nail is enough hard to mark on chalk. You all must know this copper is soft metal. Copper is soft metal. Iron is hard metal. You all know this. So if we take a piece of iron nail or any iron object and rub with a copper object, what happens? There will be marking on the copper. But copper cannot mark on iron. Similarly, diamond may mark on all the substances. Nail cannot mark on copper, but they can mark on nail. So this is very important point to note about the carbon diamond. And they are allotropes. They are allotropes of carbon. Now what are allotropes? Allotropes are substances of an element or different forms of an element having same chemical property. Allotropes are chemically same, but allotropes are physically different. So these are two allotropes of carbon. Third one is what? Fullerene. Third one is fullerene. Fullerenes are the synthetic substances. Fullerenes are synthetic substances. The graphite, diamond, they are found in nature. Fullerenes are man-made. Fullerenes are made by what? Graphite. Graphite is heated by laser beam. Just I am explaining you for your knowledge. This is not in the course, but you are supposed to know this. Fullerene is prepared by boiling graphite by laser beam. You know, laser have very high temperature, very energetic laser rays are. So the fullerenes, they are converted by evaporating the vapors of graphite. You know, they rise. Then they are collected. They are condensed into suitable solvent, organic solvent like acetone or benzene. And so there is the formation of different colors. Different colors are there. So fullerenes are group of compounds, and fullerenes are the purest form of carbon. You will be surprised to know fullerenes are almost pure as diamond, because laser has very high temperature. All the impurities they go out. So children, fullerenes C60 to C250. They exist in group. They exist in group. Means one group of 60 atoms, one group of 250 atoms. So it is actually from C50. It is from C50 to 250. But the ratio of C60 is maximum. Ratio of C60 is maximum in fullerenes. C50, 100, 200, they are very less. So it is negligible. So C60 has been adopted. Just I have expressed the small story. So C60 has been taken as a